Here's the answer for day 3, problem 1. Find all real zeros of this polynomial function. There are different ways to find zeros of a polynomial, but one way is to change from function notation into equation notation. So let's rewrite this as an equation. Negative 2x to the fourth power plus 2x squared equals 0. Now that we have the equation set equal to 0, we can solve the equation, and the answers we get for x are called zeros of that original function. We could use factoring method on this. We'll factor out the greatest common factor, which is negative 2x squared. This is going to leave x squared here and minus 1 here. If we do a quick check on this with the distributive property, you can see why this is what it is. Negative 2x squared times x squared is the negative 2x to the fourth, and negative 2x squared times negative 1 is the positive 2x squared. This right here is a difference of squares and factors farther. So we have our negative 2x squared at the beginning, and we have x plus 1 times x minus 1. And that's all still equal to 0. Now let's take each of the 3 factors that we've created and set them equal to 0 so we can solve. We have negative 2x squared equals 0, the x plus 1 equal to 0, and the x minus 1 equal to 0. Solve each of these. This first answer turns out to be x equals 0. This one here is x equals negative 1, and this one here is x equals positive 1. Here are our 3 zeros of the original function. Substituting any one of those numbers in place of x will make that polynomial turn out to be 0. Now day 3, problem 2. Sketch the graph of this function. This is a logarithm function. It's a base 10 log. So if we're going to graph this by hand, we can do that by substituting various numbers in for x and then evaluating the output values to find the dots on the grid. A good number to plug in for x whenever you have a logarithm function is to put in a 1. 10 to what power makes 1? And that answer is 0. So when x is 1, the function value is 0. 1 comma 0 is a dot on the function. Another good number to put in for x, if the base is 10, is to put in 10. 10 to what power makes 10? And that answer is 1. So when x is 10, the function outputs 1. 10 comma 1 is a dot on the graph. So with these 2 dots, we can draw in a curve and then swing it down, and using the y-axis as an asymptote line, draw really close to the y-axis without actually touching it here.